Okay, in section 3.2, talking about polynomials, and you got polynomials of a function of this form. This is the form the book uses: a sub n of x to the n, a sub n minus 1, x to the n minus 1, and so on. I prefer examples like this that are concrete, like minus 6, x to the fifth, positive 1, x to the third, and so on. And so this is these are ways of talking about polynomials of different degrees. Alright, so we're talking about polynomials. This is a polynomial of degree 5. This is a polynomial of degree 3. So the degree of the polynomial is your highest exponent, highest power. Coefficient is the number in front of x, or the constant term. So here your coefficients are minus 6, 4, minus 7, 8, negative 5, 2. Okay? And then you've got coefficients of 1, 2, negative 1, and so on. Alright? The leading coefficient is the number in front of the highest term. So leading coefficient of minus 6, leading coefficient of 1. Alright? So your leading term is the highest powered term. And a term is simply something that's being added or subtracted. Can have a letter and a number, or just a number, or just a letter. Alright? Now we're talking about the basic graphs of polynomials. Y equals x, y equals x squared, x cubed, x to the fourth, x to the fifth. So notice, even powers, they both shoot up. Odd powers, they go down to the left and up to the right. Okay, notice all polynomials have smooth curves. There are no breaks and no sharp points. And your end behavior, if you notice, your end behavior when your leading term is positive 1, which all of these guys have a positive 1x to the fourth, 1x to the third, 1x to the second, 1x, so your a is positive. They look just like an odd power would be expected to be, just like x cubed, up to the right, down to the left. An even power, just like x squared, up to the left and right. Now look what happens when a is negative. It flips. Instead of down left and up right, it's up left and down right. Instead of both up, it's both down. And that's what the difference of a in the odd or even degree does. So even degree, it's going to look like x squared or negative x squared. Odd degree, it's going to look like x cubed or negative x cubed. Okay? Now there's x-intercepts, and these are also called zeros. And to solve them, you just let p of x equal 0 and find these x-intercepts. Now there's an intermediate value theorem. It basically says if you got some points a and b, and p of a and p of b are opposite signs, meaning one's above the x-axis, one's below the x-axis, there exists a c in between them, such that p of c equals 0. In other words, if you got some number below and some number above, in order to go from this one to that one, you're going to have to cross somewhere. So they're saying when they're opposite signs, you're going to find another 0. Now when you're graphing things, you got to do 4 steps. Step 1, find all the zeros, or x-intercepts, same thing. Check some test points. Take values, a table of values to indicate whether the polynomial is above or below the x-axis. Also find the y-intercept. Then consider the end behavior. Then number 4, graph it. You'll need to get some extra values just to figure out how this graph is shaping up. Now another thing you can consider is called multiplicity. A graph near a 0 of multiplicity m. So you've got this extreme polynomial here. So x plus 4 to the 71. That's x plus 4 has a 0 at negative 4, but its multiplicity is 71. X minus 5 to the 47. Well, x minus 5 has a 0 of 5. Multiplicity is 47. Okay? X plus 9 has a 0 of negative 9. Its multiplicity is 1. And this one has multiplicity 5. Now what does that mean? Well, if it's an odd multiplicity like all of these are, it's going to pass across the x-axis. It's going to come from above to below, or from below to above. Now if it's even, none of those are even, but it can be even, it will bounce from coming down, bouncing and going back up, or coming up bouncing and then bouncing back down. So in other words, if these guys have an exponent that's even, it bounces. If these guys have an exponent that's odd, it passes through. Okay, so the first one asks you, they give you 4 graphs and they ask you which one is a polynomial and why aren't the others polynomials. Well, the first one has a sharp point to it, so it can't be a polynomial. The second one has this nice smooth curve, so it works. Number 3, it has a break in it. You can't have a break. And number 4 has a sharp edge to it. Can't have that either. So number 3, it says if C is a 0, then P of C equals 0. X minus C is a factor of P of X, and C is a x-intercept. So C is a 0, C is an x-intercept, and x minus C is a factor. You can say the same thing about C in those 3 ways. Number 4, which of the following statements couldn't possibly be true? Well, A is not true. It says degree 3. Well, we know with degree 3 it can only have 2 changes in direction to it at most. But they're asking us for 2 minimums and 2 maximums. Well, that's not possible. It will only have at most 2. And the other 2 are possible. Let's look at number 9. It says describe the end behavior and match it with one of the graphs. Alright, so this one is degree 3, and the leading term is 1, positive. So A is positive. Degree 3, it's going to look like x cubed, down to the left, up to the right. Or in other words, as x goes to infinity, off to the right, y goes to positive infinity. As x goes to negative infinity, to the left, y goes to negative infinity. And it matches up like number 3. 10, when you multiply this guy out, you get degree 4, or even. A is negative 1. So even and negative means both are pointing downward. So as x goes to infinity, y goes to negative infinity. And as x goes to minus infinity, y goes to minus infinity. 11, this one is degree 5, or odd, and A is negative. So it's going to look like negative x cubed, up to the left and down to the right. So as x goes to infinity, off to the right, y goes downward to minus infinity. As x goes to the left, or minus infinity, y goes up to positive infinity. And number 12. 12 shows you something of degree 6, and A is positive. Okay, so it's going to look like x squared. So as you go to the right, or infinity, y goes to infinity. As you go to the left, or negative infinity, y goes to positive infinity. Alright, so number 20, they say sketch a graph, make sure your graph has all the intercepts and exhibits the proper end behavior. Alright, so you set each one of these equal to 0 and you get 3 zeros. Okay. You plug 0 in for x and you get 12. Okay, your end behavior, this guy is degree 3. If you multiply the highest power in each parentheses, you get 3x cubed, positive 3x cubed. So degree 3, A is positive 3. Okay, so it's going to look like x cubed, up to the right, down to the left. Alright, so I plotted 1, 2, 3 points, the y-intercept there. So I needed to know what we was doing at 2, way down here, and at negative 1, way up there. And so that let me know how high and how low it goes, and that gave me a pretty good graph. 21, you set all these equal to 0, and solve, and you get 4 different x-intercepts. Your y-intercept, you let x equal 0, and you get 12. End behavior, this is degree 4, and A is positive 1, because you got x times x times x times x, or x to the 4th. A is positive 1 or greater than 0. So it's even, positive A, so it shoots up to the right and left. And that's what this guy does. And we plugged all these 4 points as well as the y-intercept. So then, at this point, I knew these points here and this one, but I didn't know how far down it goes, so I checked negative 1.5. And over here, I didn't know how high it goes, so I checked negative 5 point, or positive 0.5 to see how high it goes. and 2.5. I wanted to see how low it goes there. Okay, and that gave me a pretty good picture. 27. You set each of these equal to 0 and solve, and you get 2 x-intercepts. You get a y-intercept of 3. I plugged in a lot of points here and did a lot of math. It took a long time. This thing is degree 4, because this is roughly an x squared, and 1/12 x to the 4th. So a is positive and degree 4. So it looks like x squared. Shoots up to the right and down to the left. And if you notice, the multiplicity is 2 for each of these, so it bounces on each one. Now the fact that you know that this shoots up forever tells you that it comes down here, and you know it's got to bounce, so it's coming down and it's going to bounce up. And you know it's got to cross at the y-intercept that you found. Okay? Then it curves down, you know it's got to touch here, and you know it's going to bounce as well because it's even multiplicity. And then it matches with the up to the left forever. So your end behavior, your x-intercepts, your multiplicity should all combine to give you the same answer. Okay, now this one, x-intercept, you find each of these guys. Okay, your y-intercept is 8. Your end behavior is 5 because this is x to the 2nd, x to the 3rd for x to the 5th, or 1 x to the 5th. A is positive. So it's going to look like x cubed, down to the left and up to the right. So we know it shoots up this way and down this way. We just don't know what it's doing in here. But we know at -2 it passes through, and we know at +1 it bounces, because at +1 its multiplicity is 2, so it's going to bounce, and at -2 its multiplicity is 3, so it's going to pass through.